what is a Leontief production function, right? And we have covered what is a linear production function. We revised these in detail, right? Today, I want to go ahead and I want to pick up on what is Cobb-Douglas production function. So as the name suggests, Cobb-Douglas production function is given by two individuals, Cobb and Douglas, right? They gave this production function, right? So what we intend to do today is take this in detail and understand what is Cobb-Douglas production function. Okay, take it up. So let us go ahead and start with the functional form which is used to represent this Cobb-Douglas production function. अब यूजुअली स्पीकिंग जब भी हमें ये Cobb-Douglas प्रोडक्शन फंक्शन को रिप्रेजेंट करना होता है, we represent it as Q is equal to A, L to the power alpha, K to the power beta. Okay. This production function, it is also called as well-defined production function. क्यों बोलते हैं हम इसे well-defined production function? Because generally speaking, whatever we want to do with the production function, जो भी हमें generally एक production function में properties चाहिए होती हैं, all those properties are there in this Cobb-Douglas production function, right? So because it satisfies all the properties of a well-defined production function, that is why it is called as a well-defined production function. अब वो properties क्या हैं? What is a well-defined production function? So well-defined production function has the following properties. पहले हम उसकी properties को एक बार देख लेते हैं. So what is a well-defined production function? किसे बोलते हैं well-defined? First of all, we need technology feasibility. Technology feasibility. The technology feasibility क्या कहती है? That with the given inputs, we should be able to produce the maximum output possible. जो भी हमें inputs दिए गए हैं, उससे हम maximum output को produce कर पाए. We have to remain efficient, right? So the technology feasibility says that whatever input combination we are using, we should be able to produce maximum output possible, right? Second beta, non-negativity. Non-negativity basically goes ahead and says that your input and output must be non-negative. Mane, I can only use L greater than equal to 0, K greater than equal to 0, and my output should also be Q greater than equal to 0. Third, positive marginal product. तो हमारे प्रोडक्शन फंक्शन से जब हम मार्जिनल प्रोडक्ट निकाले, मार्जिनल प्रोडक्ट ऑफ लेबर और मार्जिनल प्रोडक्ट ऑफ कैपिटल, it should be positive. So how output changes as labor changes should be greater than 0. How output changes as capital changes should also be greater than 0, right? So you should have positive marginal product. Okay. But a fourth, diminishing marginal product. Marginal product positive तो चाहिए. We need a positive value for marginal product. But at the same time, marginal product should also be diminishing in nature. Diminishing माने what? माने if I differentiate marginal product again with respect to labor, it should be less than 0. तो marginal product positive तो है. But as we increase the labor, the additional output created should keep decreasing, right? Additional output should eventually decrease, right? So we can also write this as del square Q by del L square should be less than 0. माने जब हम double differentiate करें, we should be able to go ahead and get that less than 0. Similarly, del MPK by del K should be less than 0, which means when I double differentiate Q with respect to K, it should be less than 0. Right? So if I combine these two things together, beta, iska kya matlab hai? Positive marginal product says that my marginal product curve should be in first quadrant. Isko bhi mila lete. It should be in first quadrant. Mane, I understand that if I take labor here and marginal product here, ठीक है? So हमें पता है that here labor has positive values. Here marginal product is positive. Here labor has negative values. And here marginal product is negative. So ये वाला property क्या था that labor can only be non-negative. माने I can only be here. Labor का value सिर्फ here. And this property says that I should have positive marginal product. Means marginal product can also be only here. So it means this is clear that I have to be in first quadrant. I cannot have negative values of marginal product or negative values of labor. So I can remove this. Then it says that marginal product is diminishing. Diminishing means agar first unit of labor se I get some marginal product, so second unit of labor se marginal product should be less. Third unit of labor se marginal product should be even lesser. So it means that as I go ahead and as I increase the labor, the additional marginal product should decline. So I can go ahead and get something like this beta. Marginal product should be downwards. इसका slope negative है. यही हमने यहाँ लिखा है. We have written that exactly here. That when I find the slope of marginal product of labor or the slope of marginal product of capital, it should be less than 0. Right? That's what we mean. Okay. Then, for any well-defined production function, we should be able to find returns to scale. हम उसका returns to scale निकाल पाए, right? And it should be a continuous production function. माने there should not be any breakage. ऐसा ना हो कि I start drawing a production function and then there is a break and then another part is there. Now, it has to be continuous in nature and it should also be differentiable. And seventh, this is just additional, that it should be convex to origin. In bracket, strictly convex. It should be strictly convex to origin, right? So if these things are defined, then well-defined production function will be there. Well-defined production function क्यों चाहिए हमें? हम क्यों किसी और production function के साथ काम नहीं कर सकते? Why do we need well-defined production function? Well, we need it so that we can develop theories, right? अगर कोई भी हमें चीज पढ़नी होती है, then we always begin with the perfect example and then we introduce exceptions to those, right? So a well-defined production function can be thought like a perfect example, जिसमें आप cost minimization, profit maximization, input-output elasticities, relationships, सब कुछ कर सकते हो. You can do everything with it, right? And once you understand the well-defined production function, then it is okay to go ahead and work with other production functions also. उसके बाद आप बाकियों में भी बाकियों को भी understand कर सकते हो, right? So that's why well-defined is important. Now, what we are saying is, coming back to where we started, is that this Cobb-Douglas production function that we have, this is in fact a well-defined production function. ये एक well-defined production function है, right? Now, in this Cobb-Douglas production function, we can go ahead and see that the A factor, ये जो first factor है, this is called as the technology factor. It's also called as total factor productivity, right? Then second, beta, you have alphas and betas, which are your output elasticity of labor and capital. These alphas and betas, these are called as your output elasticity of labor and capital. इस पे थोड़ा सा एक मिनट, let's focus a bit on this. What is the meaning of output elasticity? What is the meaning of output elasticity? तो एक बार इस तरह ध्यान से देखते हैं. See, output elasticity basically goes ahead and tells me what is going to be the percentage change in output when there is going to be percentage change in input. So, output में कितना change आएगा जब input में change आएगा, that is basically your output elasticity, right? Let us go ahead and look at our production function. तो हमारा जो production function given है, that is A, L to the power alpha, K to the power beta, right? If I ask you what is the output elasticity with respect to labor, it will go ahead and mean the percentage change in output due to the percentage change in labor. माने हम पूछ रहे हैं how output changes as labor changes into initial labor by initial output. So let us go ahead and differentiate this with respect to L, with respect to labor. So if I differentiate this, what will I get, beta? D. It will be a partial differentiation क्योंकि दो inputs हैं, so I can write del here, right? So if I differentiate my output with respect to labor, I will get A, power comes down, power reduces by 1 into K to the power beta, right? So I will write this here, A alpha, L to the power alpha minus 1, K to the power beta into L by Q. ठीक है. अच्छा, what is the value of Q? क्या दिया हुआ है आपको Q? ये वाला value दिया हुआ है. So we can plug this Q here. I will get A alpha. Since base is same, power will get added up. तो L का power हो जाएगा alpha minus 1 plus 1 K to the power beta upon A L to the power alpha K to the power beta. This is the value of output. So this will be alpha. ये मैं alpha बाहर ले रही हूँ. A L to the power alpha K to the power beta upon A L to the power alpha K to the power beta, and this will cancel. So I will be left up with alpha, right? So we can say that the output elasticity with respect to labor is alpha. इसका क्या मतलब है? Suppose in exam, you are given this production function that Q is equal to A L to the power half K to the power half. And question says that if labor increases by 10%, then output will increase by, and बेटा आपको कुछ options दिए हुए हैं, 20%, 10%, 5%, not increase. You're given some options. Okay, and you have to tell what will be the right option. then you can go ahead and use this formula. तो अब हमें formula से क्या पता है? That percentage change in output due to percentage change in labor is half. ये alpha. And labor is changing by 10%. So we can say percentage change in output by 10 is half. तो माने percentage change in output will be 10 by 2, which will be 5. Which will be 5. तो यहां से हमें एक क्लैरिटी आ गई है that the percentage change in output will be 5. Right? Similarly, we can say कि यहाँ पे ये जो पावर है बीटा, this is the percentage change in output due to the percentage change in capital. How much output will change when capital changes? That is your beta. उसको हम बीटा बोलते हैं, right? Okay. So alpha and beta are your output elasticity of labor and capital respectively. Okay. अच्छा, now let's talk about homogeneous production function. कि एक homogeneous production function क्या होता है? So homogeneous production function is any production function which satisfies this property. So what is this saying? ध्यान से देखो. When I am scaling labor and capital by t, मैंने लेबर को भी टी से स्केल किया और कैपिटल को भी टी से स्केल किया, by what will production function scale? By what factor will production function scale? Right? So for example, let's say that your production function is a L to the power alpha, K to the power beta. Now, beta, I am creating a new production function in which L is scaled by the factor T. L की जगह मैंने TL लिख लिया. And K is also scaled by the factor T. तो K की जगह पे मैंने TK लिख दिया to the power beta. So I am going to go ahead and get A, T to the power alpha, L to the power alpha, E to the power beta, K to the power beta. Okay. So this will be T to the power alpha plus beta. When base is same, power gets added up. Into A, L to the power alpha, K to the power beta. And this is your original production function. देखो. So this will be T to the power alpha plus beta into Q. ये हो जाएगा Q dash. So the production function has scaled by the factor this. T to the power alpha plus beta. When we scaled labor and capital by T. This is a homogeneous production function because we can take the T out. हम T को बाहर निकाल के हमें ओरिजिनल प्रोडक्शन फंक्शन वापस मिल पा रहा है, तो इसको हम एक होमोजेनियस प्रोडक्शन फंक्शन बोल सकते हैं. और यहाँ पे T का जो पावर होगा, इसको हम डिग्री ऑफ होमोजेनाइटी बोलते हैं. इसको हम डिग्री ऑफ होमोजेनाइटी बोलते हैं. Now, if this alpha plus beta is greater than 1, माने when we scale labor and capital, output will scale more than that. अगर लेबर और कैपिटल को डबल करते हो तो आउटपुट डबल से ज्यादा हो रहा है. When alpha plus beta is more than 1, it is called as increasing returns to scale. If alpha plus beta is exactly equal to 1, constant returns to scale. If alpha plus beta is less than 1, decreasing returns to scale. तो ये पावर डिटरमाइन करेगा कि what returns to scale you have. ठीक है. Let's come back here. This is the property that we have written, that the degree of homogeneity of this Cobb-Douglas production function is alpha plus beta. ठीक है। नाउ no, you cannot have different coefficients of labor and capital. You need to scale the inputs by the same factor, right? So you can either double both the inputs or triple both the inputs. This is not possible. You cannot do this. ऐसे नहीं कर सकते हो कि आप ऐसा कुछ लिख दो 12 3K. This is not done. You have to scale them by the same factor. I can scale it by 2 or 3. So it can be either this or it can be this. But it has to be the same factor. Factor same होना चाहिए. Okay. Now, next beta, it has constant elasticity of substitution. इसके बारे में I will just talk in a while. We'll keep it towards the end. The MRTS is MPL by MPK, which is alpha by beta K by L. तो इसके बारे में बात कर लेते हैं. So now we understand that we are talking about a well-defined production function, and वो well-defined production function कुछ ऐसा दिखता है. This is how my Cobb-Douglas production function looks. Here I have labor and here I have capital. Now the slope of this well-defined production function, of this Cobb-Douglas production function, it is dk by dl. ये हमने लास्ट क्लास में बात की थी that it is dk by dl. और अगर हम यहाँ पे देखें किसी भी पॉइंट पे स्लोप हम निकाल सकते हैं by drawing a tangent line to it. आप एक tangent line draw करो. That will be the slope at that point. Now the slope of the Cobb-Douglas production function, अगर हम उसका वैल्यू निकालना चाहें, so dk by dl can be written as mpl by mpk, right? And the slope is called as MRTS, marginal rate of technical substitution. So MRTS is MPL by MPK. ठीक है. अब हम अपने प्रोडक्शन फंक्शन की बात करते हैं. A L to the power alpha K to the power beta, right? So if I find out marginal product of labor, this will be how output changes as labor changes. ठीक है बेटा? So this is going to be A, power comes down, power reduces by 1. And what will be MPK? How output changes as capital changes. So it will be A, power comes down, power reduces by 1. अब इनको हम डिवाइड कर देंगे. So when I will be dividing, A and A will get cancelled. And now this is L to the power alpha minus 1 and this is L to the power alpha. माने डिनोमिनेटर में L का पावर 1 से ज्यादा है. Just think about it. Suppose I tell you alpha is 2. तो न्यूमरेटर में L का पावर क्या हो गया? 2 minus 1 माने L. और डिनोमिनेटर में L का पावर क्या हो गया? L square. So L divided by L square will be 1 by L, right? So numerator में power of L is 1 less than the denominator. So what we can go ahead and we can do is that we can cancel and I will have 1 extra L in the denominator. उसी तरीके से power of K is beta and here it is beta minus 1. So numerator has 1 more power of K. So when I want, I can just cancel this and I will have 1K in the numerator. So हमारा जो MRTS आएगा, that will be alpha by beta into K by L. That will be the slope of this production function. So we can go ahead and we can say that the slope of the production function MRTS, it will be alpha by beta into K by L. ठीक है बेटा, इसके बारे में मैंने पहले ही बात कर दी है that if alpha plus beta is 1, then you have constant returns to scale. If it is more than 1, increasing returns to scale. And if it is less than 1, decreasing returns to scale. ठीक है. अच्छा, अब एक बार हम इसके बारे में बात करते हैं. Let us think about and ask ourselves, what is a homothetic production function? ठीक है. But a homothetic production function is any production function where MRTS is a function of capital by labor. अगर हम MRTS को, अगर हम स्लोप को इनपुट के रेशियो में रिप्रेजेंट कर पाए, तो उस प्रोडक्शन फंक्शन को होमोथेटिक प्रोडक्शन फंक्शन बोला जा सकता है. It can be called as a homothetic production function. Let me give you an example. Here when we found out the MRTS, जब हमने यहाँ पे MRTS निकाला, so हमारा MRTS alpha by beta K by L आया है. It means that MRTS can be written as a function of K by L. MRTS K by L input ratio पे dependent है. Then it is a homothetic production function. अब homothetic production function होता क्या है? What is a homothetic production function? So a homothetic production function is any production function such that when I pass a ray through the origin, the slope remains unchanged, right? The slope remains unchanged. These isochons, they are radial expansion of each other. क्या मतलब है इसका? मतलब अगर मैं एक रे थ्रू ओरिजिन पास करूं, बेटा रे थ्रू ओरिजिन का ये प्रॉपर्टी है दैट ऑल पॉइंट्स ऑन दिस रे रिप्रेजेंट सेम x:y रेशियो. एज लॉन्ग एज आप एक रे पर हो, आपका जो दो कोऑर्डिनेट्स का रेशियो है दैट विल ऑलवेज बी कांस्टेंट. जैसे फॉर एग्जांपल, suppose if I tell you that this is a ray through the origin and here x is 1 and here y is 3, फिर x 2 हुआ तो y will definitely be 6. If x is 3, y will definitely be 9. तो रे थ्रू द ओरिजिन का ये प्रॉपर्टी है दैट whenever you go ahead and you find out the ratio, तो ratio will always be constant. तो अगर मैं यहाँ पे suppose if I take this as labor and this as capital, तो I am saying that point A, B and C पर the capital labor ratio is fixed. So A पर भी K by L is 3/1, which means 3:1. Point B पर K by L is 6/2, which means 3:1. Point C पे K by L is 9/3, which means 3:1. So every point on the ray through the origin, जितने भी point है ray through the origin में, we are saying that we have constant capital labor ratio. ठीक है. अब सपोज आई गो अहेड एंड आई ड्रॉ एन आइसोकॉन्ट. तो अब मैंने क्या किया कि मैंने यहां पर एक आइसोकॉन्ट पास कर दिया और यहां पे भी आइसोकॉन्ट पास कर दिया और यहां पे भी. तो हमने इस आइसोकॉन्ट का स्लोप क्या निकाले बेटा? अल्फा बाय बीटा के बाय एल. अल्फा बाय बीटा कांस्टेंट है. अल्फा बाय बीटा इज अ कांस्टेंट. एंड वी नो दैट एट पॉइंट ए, बी एंड सी capital labor ratio is also same. 3:1, 3:1, 3:1. तो माने this K by L, this is also fixed on all points A, B, C, which is 3 in this case. तो ये point हो गया that when I find MRTS at point A, B and C, ये जो MRTS आएगा, this MRTS, this will be the same. It will be the same बेटा. क्यों सेम आएगा? बिकॉज MRTS का वैल्यू हमारा आया है अल्फा बाय बीटा के बाय एल. राइट, वी हैव गॉट MRTS एज अल्फा बाय बीटा के बाय एल and we have found out that our k by L is fixed at 3. तो अगर k by L 3 पे फिक्स हो गया, alpha by beta anyways is fixed, so we will go ahead and we will get constant MRTS. तो दिस इज अ होमोथेटिक प्रोडक्शन फंक्शन जो ये बोलता है that when you pass a ray through the origin, when you pass a ray through the origin and then you find MRTS, चाहे आप MRTS पॉइंट A पे निकालो, पॉइंट B पे निकालो, पॉइंट C पे निकालो, you will notice that the MRTS is coming out to be the same. ठीक है, this is homothetic production function. इसी को ही हम ऐसे भी बोल सकते हैं that the isocons they are radial expansion of each other, they are scaled expansion of each other. माने हमने कुछ भी नहीं किया, बस हमने स्केल करते गए. हाँ, जैसे फॉर एग्जाम्पल पॉइंट ए बी और सी में अगर आप देखो तो आई हैव जस्ट मल्टीप्लाइड बाय 3, right? I've kept the ratio the same. I've 3 रहा, then I scaled it to 6, then I scaled it to 9. So 3 का table है 3, 6, 9. I'm just scaling the points, right? So we can also go ahead and say that homothetic production functions, they are radial or scaled expansions of each other. Okay. Now, let us go back. अच्छा ठीक है. Now just take a minute, think about it, and tell me in the chat window, all homogeneous functions are homothetic, but all homothetic are not homogeneous. Think about it. Tell me if it is true or false. All homogeneous are homothetic, but not all homothetic are homogeneous. Different quantities of labor and capital, yes, but in the same ratio. You notice that labor and capital are used in same ratio at all these 3 points. तो मेरा statement देखो बेटा, what I am saying, all homogeneous functions are homothetic, but not all homothetic function are homogeneous. True or false? Okay, let's see. So homogeneous function क्या है? होमोजेनियस फंक्शन वो फंक्शंस हैं जिसमें हम एक इनपुट को जब सेम अमाउंट से स्केल करते हैं तो वो स्केल्ड फैक्टर हम बाहर निकाल पाते हैं. वी आर एबल टू टेक द स्केल्ड फैक्टर आउट. ठीक है, माने अगर मैंने लेबर को लैम्डा से स्केल किया, कैपिटल को लैम्डा से स्केल किया, सो आई कैन टेक दिस लैम्डा आउट and get back my original production function, right? So I am able to get back my original production function back. ठीक है, अब क्योंकि मैंने लेबर और कैपिटल को सेम अमाउंट से स्केल किया था, all isocons are scaled versions of each other, right? And therefore I can say that labor by capital ratio would have been unchanged. Labor and capital ratio would have been unchanged. क्यों? क्योंकि labor and capital are scaled by the same amount. And scale करने के बाद I am able to get that scaling factor out and I am able to go ahead and get it as lambda to the power r into FLK. So since labor by capital ratio is unscaled, we can say that it is also homothetic production function. It is also homothetic production function. Okay. Let's take an example. Take an example. I've already taught you Q is equal to A, L to the power alpha, K to the power beta. Is it homogeneous? Yes. ये होमोजेनस है. क्यों होमोजेनस है? क्योंकि अगर हम अल्फा को लैम्डा से वी स्केल एल बाय लैम्डा, वी स्केल के बाय लैम्डा, तो हम ये लैम्डा फैक्टर को कॉमन लेके बाहर कर पा रहे हैं, राइट? सो वी आर एबल टू राइट दिस एज लैम्डा टू द पावर alpha plus beta, a L to the power alpha, K to the power beta, lambda to the power alpha plus beta into original Q. So we are able to take this lambda factor out. Therefore, it is homogeneous. Is it homothetic? Is it homothetic? Yes. Because when we found out its MRTS, जब हमने इसका MRTS निकाला था, the MRTS was coming as a function of the ratio of the two inputs. वो K by L का function आ रहा था. So yes, it is homothetic. Because MRTS is a function of K by L. तो ये homogeneous था? Yes. ये homothetic था? Yes. So if homogeneous, it is homothetic also. No problem. But now, give me an example, think of a counter example, where the function is homothetic but not homogeneous, right? It is homothetic but not homogeneous. Can you think of that example? Anyone? Take a while. Just think, write it in the chat window.